Hello everyone, I'm Lalchan and we will be talking about how we can improve DevX at our organization. So developer experience in an organization is a factor of multiple variables. Over here we are intended to discuss how DevX has evolved as PhonePe organization evolves. We will go over the challenges which we faced and solution that we took in different phases of PhonePe's growth and hope that this will help you understand how to bring forth changes in your organization. Okay, to start with, our main focus was to be the first UPI app in the market, and UPI was new in the India. So we were very excited and positive about how it can potentially solve the different aspect of payments in India. Our main focus was to build first UPI app in India, and this was not an easy goal. UPI was a new government-led project in the financial sector. Integrating with any new system is hard, since this involved multiple systems, made it even harder. So all in all, the goal was to deliver MVP at rapid pace, with UPI system evolving and catering to the more use cases, example B2B, B2C, P2P, recharge and bill payment, etc. That time we had 3 developers to do the job, and code base was fairly small, hardly 10 Gradle module, and of course there was no user base at that time. But goal was to make a product which helps enabling digital payment in India. So whole system pipeline was new and it involved multiple parties, including third parties. Let's see life cycle of a transaction in UPI. To start with, it gets triggered from the PhonePe application, which include NPCI SDK as part of it. Then transaction moves to the PhonePe backend. From PhonePe backend, it moves to the external system, which is PSP Bank, Payment Service Provider. From there, it gets redirected to the NPCI, National Payment Corporation of India, who has built UPI protocol. And from there, it goes to the destination bank, where money movement take place. And in the reverse path, it basically follows the same cycle. Okay, so the challenges which we faced during this, since all involved system were newly built and integration was new, so our challenges primarily around integrating with the system. Integrating testing was usually the cause of many issues, as there were multiple point of failure, too many frequent changes in the API contract, instability of the API, intermittent failures, etc. And all of this made integration difficult. And also traceability was not there, hence debugging a particular issue and rectifying it was basically more of a trial and error approach. New changes would break existing functionality more often than not. And with this wide variety of changes coming into the system, it was really hard to define exhaustive testing strategies. Anything could break anywhere in the system, and visible impact can only be seen on the application. Security was another challenge, especially because UPI was newly designed protocol and works significantly different than existing protocols. Hence, security needs to be solved from the scratch, and there was no existing solution which we could latch on. Okay, so as part of solutioning, we started keeping the stable artifact with us. For API stability, we created 2 environments. One is the development environment and another one is the app API integration environment. For libraries, in-house and external, we started keeping a stable version with us. Basically, whenever a issue comes, we revert back to the stable version and don't block ourselves. Even we were focused heavily on rapid delivery of MVP, but we still spent a very good time on the security solutioning. We built multiple layers of security, device level security and the network level security. Delivering MVP and wide scope testing because of the multiple system involvement kind of opened the door for the failure. So we dogfooded a lot in PhonePe. Actually, PhonePe employee were the first user of the UPI, and we did a lot of penny transaction among ourselves. And basically, whole organization became QA in order to ship a stable product in the market. We also acted as a L1 support team. We talked to the customer that time and we tried to understand their pain point, and it actually helped us a lot to find out about the hidden issues.
Thanks, Lalchand. So, in the previous stage, the focus was to be the first UPI app in India, which we were able to do so. In the mid stage, our objective was to become the most trusted app. As Lalchan mentioned, security was baked into the PhonePe app from the start. Now, we had to ensure we were seen as trustworthy. For this, not only did PhonePe have to be secure, it had to just work and also be reliable. People nowadays take their phones to do payments and not their wallets. To reach this stage, we had to ensure that PhonePe would just work. Success rate was high due to how the UPI protocol was designed, and the PhonePe app ensured that we only improved on this transaction success rate. We also had to ensure that PhonePe was synonymous with digital payments. If you can pay for it via UPI, you should be able to pay using the PhonePe app. All this with about 15 developers who worked on a 25 module Gradle project and served a user base of 1 million daily active users and 1.3 million transactions per day. With 15 devs as the codebase grew, designs used across the codebase were points of concern. We had to talk about architecture and how do we ensure that the codebase scales. Our competition was being able to swipe a credit card for the transaction. If the PhonePe app takes time to process the transaction, the customer would just use the credit card instead. How could we perform better was a question we often asked. The system was brittle. As Lalchan had shown earlier, we interacted with multiple third-party systems. As such, it was possible for our users to face issues which would only surface on the app. We had to figure out where was the issue to build fallbacks or provide explicit messaging to our users. The decision of no QA team early on had to be revisited. It was not possible for us to develop the app, test all features, and also monitor the app. We would often face regressions due to uncaught edge cases. Our earlier practice of manually handing over builds to the team was not scalable any longer. Ad hoc releases no longer worked since it was hard to decide when to release. Early on, we released when we had a specific set of features completed. Now, if we released our app on every feature completion, there would be too many releases for our users. Doing a release also required some knowledge of the application ecosystem. This included Play Console access, monitoring crash reports, ANRs, and other systems, and hence was handled by the senior 3 devs. However, there soon became a bottleneck for releases. How did we go about solving these? We realized we needed a continuous integration setup, at least to complete our development pipeline. Setting up a CI system helped simplify the handoff between devs and the QA team. We spent some time doing code reviews. This was used to help onboard new developers to our code base, since the code was evolving fast. Any documentation we created could also be outdated. As such, we chose to do code reviews together to provide context on the code base. We decided to make deliberate choices on our code base. This included creating a lot of base level components like the network stack, the persistent stack, etc., and majorly setting up some basic conventions and design patterns on the code base. This was to make it easier to reason with how the codebase scales. Note that we mentioned conventions and not best practices. This is because we needed our codebase to be predictable so that it was easier to debug, easier to make large-scale changes, and also estimate how long a task would take. Best practices do not usually age well, and we would not give us a uniform codebase. Hence, our choice for conventions over best practices. We incepted and scaled our QA team. To keep the communication overhead low, we involved the QA team as a part of the development and release cycle. They were also our stakeholders and would help decide how to go about testing a feature and also help in defining requirements. We also introduced a bi-weekly release train, and the schedule for the release train would be published for an entire quarter at a time. This helped in enabling teams plan more long-term. It also drastically reduced scope creep since there was always the next release available. Since there was a bottleneck on the 3 devs for releases, we introduced the concept of a release manager. The release manager would follow a release checklist that detailed all the steps of a release. A bonus was that anyone in this role also learned a lot about mobile app release cycle and also interacted with the wider team. The checklist was a great benefit for us and a first step towards release automation. This not only called out steps in a release, but also talked about systems to monitor post a release. Since we now cater to a large existing user base, we also brought in some regression test suites, like an app upgrade test. Note that these are not automated tests, but essentially a part of our release checklist and also known as L1 test cases, which anyone could add critical features to. These test cases helped catch several regressions and also had the benefit of the engineering team being mindful of these scenarios while designing features. Now that we had established ourselves as trustworthy to our users, we had to figure out how to do this for a lot more users. Payments requires two parties. The second party could be your friend, the shopkeeper downstairs, your electricity provider, or even your cab driver. We had to be able to support all forms of these payments. As such, being plugged into that ecosystem was the name of the game. Maintaining user trust at scale on a mobile app refers to providing a great experience to all the users of our app. Word of mouth has been an important medium of growth for PhonePe. Our users being able to trust the PhonePe app and recommending it to their friends and family was critical to our success, as with the ability to badmouth the PhonePe app too. As such, we had to make sure that we built a product that people trusted to handle their money. Protecting them from frauds and scams was a critical requirement now. All of this with a 40-member strong team working on a large Android project of about 100 Gradle modules, catering to 30 million daily active users and 35 million daily transactions. So what challenges did we face here? The 100 plus modules manifested in the form of multiple in-house frameworks and SDKs. This means we had a lot of layers in place, which made debugging harder. It increased the points of failures and also made modifications to the lower level frameworks harder. As with working with large code bases, the same feature set would be duplicated into multiple frameworks, so making an app-wide change would not be easy. Our earlier choice of having conventions on the codebase helped with keeping this problem a bit more manageable. As our user base grew in non-metro cities, we saw a large variety in user factors. In the last quarter of 2021, we had 630,000 transactions done in Ladakh alone, an area with a population of 300,000 with a minimum elevation of 8,000 feet. Obviously, network conditions are not great there. The PhonePe app also needs to work under these conditions. There were also multiple types of users. Some were power users who used PhonePe for everything, versus occasional users who sparingly used the app, versus first-time mobile phone users who needed onboarding, and non-English speaking users who needed the app in their native language. Currently, the PhonePe app supports 11 languages. These usually good to have features now became mandatory for us. We also had different types of products in the mix. Some were stable products, and an issue in them could have dire consequences on a bottom line. Some of them were testing the waters to find a fit, and they had to experiment more rapidly than the others. A lot of new joiners and COVID made onboarding much harder. As Android changes almost every year, there were multiple ways of doing similar things. As a result, there were multiple ways of doing the same thing in our code base too. QA teams were growing at a slower pace than developer teams, and as such, the rate of incoming features and changes was a lot more than how fast these could be tested and verified. A release would go out on a particular date, and we realized that defining a deadline was not the equivalent of having a process. How did we go about solving these? Common frameworks needed caring contributors. A central team was required to tend to this garden. This was the start of a platform team or a core team. They owned certain features, but mainly owned common frameworks. They worked on defining boundaries for their common features. Their priority was to consider the application as a whole instead of specific features. The team would proactively address issues instead of reactively solving them when the problem got out of hand. We also realized that tech-based functional teams were no longer working for us, and it was hard to balance priorities and timelines in the structure. We then decided to move towards a pod-based structure. Each pod would be self-sufficient in incepting and delivering a feature end-to-end, and hence could reason with trade-offs within the team. We also use feature flags heavily. In order to have consistent releases, we had to reduce the number of hotfixes that occurred. By using feature flags, we could remotely disable or modify a feature and reducing the number of hotfixes. Automation was also a requirement for us now. Common frameworks were largely dependent on automation. It was impossible to test all the combinations of how these frameworks were used, and hence automation helped in this regard. While working with code bases, we realized the importance of components and generalization, and we also brought the same to our automation framework. We introduced the concept of user personas in automation. This included power users, different language users, poor network simulations, and so on. The personas were created based on metrics that we had and the varying conditions under which our app was used. The abstractions in the automation framework above helped in creating multiple test scenarios that covered several types of our users. A more detailed release process was defined. While release dates were consistent, we were having difficulties in meeting them since they were treated as deadlines. Most QA teams would be given things just before the release date. We brought in more sub stages into the release process. We split these as development, feature testing, and integration testing stages. These granular deadlines helped in ensuring that we only bite as much as we can chew. QA teams could plan their testing cycles better, and it also helped us analyze which stage was taking the time. Now I'll be handing it over to Lalchand, who'll talk about PhonePe's next stages.
Thank you, Satyarth. The primary focus here is to invent and innovate on existing capability to provision for multiple businesses and multiple verticals in PhonePe. Basically, to have startup within startups. Okay, so before moving further, let's have a look at numbers. PhonePe currently contributes to 47% of UPI share in terms of number of transactions. And in terms of the value of transaction, PhonePe contributes 49% of UPI share, which essentially means the 49% of overall UPI money movement happens via PhonePe pipeline. Okay, so UPI penetration has been good in the recent past. It's kind of doubling almost every year. For instance, number of transaction in month of April in 2020 was around 1 billion, and in the month of April 2021 it became 2.6 billion, which then grew to 5.5 billion in month of April 2022. UPI dominates digital transaction in India, and if you see the trend, in 2019 UPI share was only 16%, which then grew to 63% in 2022 and projected to grow to 73% by 2026. So basically UPI transactions are growing in India with a very rapid pace. Hence, PhonePe as a market leader in UPI will grow exponentially as UPI uses increases. Objective of organization was to launch 20 business and having multiple apps. Till now we know how to solve it for a business. So we looked for the ways to replicate the same across all the businesses. How we can build an infrastructure which allow us to kind of leverage the existing capabilities, so not all the business has to go via the same learning again. To do this, we had 80 developers. Code base is big now, include 150 plus Gradle module, and user base is basically 80 million daily active user and 90 million daily transactions we are processing. Okay, so what are the challenges we are facing with this stage is that with this huge user base, it's almost impossible to cover all cases generically. Android fragmentation at device, API, OEM layer, OEM needs to be addressed upfront. Certain OEMs are more popular than others. We need to ensure that changes which we make does not impact a large section. PhonePe releases APK to the multiple app stores, example Samsung, Vivo, etc. And it also has a tied up with a few OEMs where the APK goes and as a pre-bund APK. So now pre-bund APK needs to go via separate certification and third-party testing plus compliance. So all those things needs to be handled, and we apparently needs to generate different variant of applications to launch on different app store and as part of pre-bund. Okay, so sister apps coming into picture now. Modularization and reusability of the code base is necessity, and demand for amount of code base which needs to be shared across increased drastically, as not everything was built as a library. So modernization was there, but carving out as a library needed additional effort. Automation was an afterthought, and coverage was still not great, so we had heavy dependency on manual verification. Functional correctness was not measured across the user base as part of a different stage rollout. Example, we would measure CFU but not transaction success rate. NFR now started also becoming a problem. Um, Example, if app launch time increases, transaction drops, and which affects the business. Since release were becoming larger in terms of amount of things which are going as part of it, and that too via manual verification, this started leading to kind of burn out the QA folks and also sometime affecting the release quality. Pushing a particular fix in the stage rollout becoming bit more larger, apparently take live phase of a release becoming heavier because same um, repetition of the process will happen for the manual verification part. So what we did for the solution? Automation became heavy focus and investment area. Regression sanity suit needs to be run multiple times as part of the train and contribute to take live phase. So to start with, we automated that. Building automation for app upgrade and all critical flow was become essential. An example, payment, login, scan QR, etc. So that we always ensure that we won't break happy case. Created performance test suit against and running them against every release candidate, and also build a periodic jobs to run this test suite to have a handle on the NFRs. And we also establish the baseline, basically if for functional and the non-functional matrices, and if that baseline breaches, and that would be taken very seriously. Unit test cases were cheaper, so we started implemented unit test cases and started focusing to increase the code coverage, especially for the frameworks which were cross-functional. Increase in the code base started impacting the local build time as well, and CI pipeline, hence release process. So the core team which was formed in the last stage started investing dedicatedly on the build time CI pipeline with the point of view to improve the developer productivity. Example, they running unit test cases in parallel, provide provision for more infra so that multiple pipeline can run in parallel. Prioritization between the test suite, when to run which test suite, so efficiently we can run, because running whole test suite at every single time at MR level would go more lot of time and resources. We also enhanced the pipeline capability. Sonar was integrated in the code base and run as part of every MR. We mandate 35% unit test coverage for every single new MR which is coming in. Few quality guardrail also got built as part of it. Example, APK side check. And this also has kind of saved us a couple of times where the authentication of the code base has broken. Hence, unauthenticated code would have landed to the market, which could have got this security concern. Code review were also automated for smaller nitpicks. Example, correct label was assigned as per the correct target release date. Jira addition to the MR, self-reviewed. MR has a required sign-off. MR can only get merged if pipeline is green, etc., etc. We consider code base to be built as a SaaS instead of directly user-facing feature. So while designing all of these things, we were upfront mindful to design it as a library and not just solving the case in hand. And we also went ahead and carved few cross-functional capability from the existing code base as a libraries. Example, network, cryptography, config management system, push notification, analytics, performance, etc. And it helped a lot in terms of sharing the reusability of the code base across the stack. Okay, so release was kind of marathon and not a sprint. Basically, 2-week release cycle was not scaling and hurting the team. There was barely a time between the development, feature verification, and repeating the process. So we had to immediately move to the 3 weeks release cycle. And while doing so, we just increased the QA phase of the release cycle, as release stability was our priority. Manual release no longer can scale. So basically we built a console which provides the parity with the current process, but now releases are system driven and now manual work essentially needs to be done. This console offers creation of train communication about the train phases, sending nudges to the team regarding when a particular phase starts and ends, notify QA once RC is available, and also sends the notifications to the org about the uh, release rollout on different stages. Apparently, release will also happens via this console only now. Okay, since we started investing into this, so our future plan involves creating an environment where developers should be able to do independent development. They can push changes to remote as soon as they are done with it. Also, release now becomes system driven and can happen independent of development cycle at defined frequency. Okay, thank you for attending this talk. We hope that it would be beneficial for you and you try to bring changes within your organization. Thank you.